Hey you guys, so I'm just gonna go over what we discussed in lecture today. Again, this is oriented usually towards the students in initial stages of math, um, and what we discussed was the terminology dealing with fractions, right, and then adding fractions, and then kind of playing around with them and applying, um, adding and sorry, excuse me, addition and subtraction of fractions, multiplication, division of fractions, and then the rules that apply to each and how to go about them, right? So again, we kind of discussed something, right? We started out with talking about the terminology. We said a proper fraction is one in which you get the numerator, which is smaller than the denominator, right? Initially, it's less than 1. It's less than a whole, right? This, in its decimal form, is 0.4, right? Or 0.40. And then we can go on and talk about an improper fraction. Oh, ugh, ugly, ugly. And this is going to be a sequence of a few videos. I don't want to make them too long, but they're going to build on each other. Improper fraction, right? That's the opposite. Where we have an improper fraction is where the numerator is larger than the denominator. So we can say 7 halves, right? Or even 5 over 2, or 5 over 2, and the list goes on. Why? Because these values are greater than 1, right? 2, 4, 6, that's 3 and 1 half, right? This, in its decimal form, 7 halves is 3 and 1 half, right? Correct? So we can see that it's greater than the whole. If you want to actually verify that, just divide 2 into 7, right? Remember, I mentioned that this division sign is also interchangeable with this operation. Basically, this operation is saying, hey, or this guy is saying, hey, do this. This is saying, hey, put it in this format, right? So we can go ahead and do that, and that's basically the process that's going to allow us to, the function that's going to allow us to visually see or convert it into a decimal. So 2 goes into 7 how many times? 3, right? 3 times 2, 6. We're going to subtract that, right? Right? So it's going to be 3 and 1 half, as we had stated, right? So that's an improper, that's a mixed number at this point, by the way, right? Or we can simply say that this is 3.5 in its decimal form, right? Okay, cool. If we wanted to verify that more, let's say, well, we know that 2 doesn't go into 1. So in order to get it fully decimal, 2 doesn't go into 1, right? So we can just add a 0, but because we added this 0, this arbitrary 0, we have to have it a point, right? So we have a decimal place. This is, by the way, that point right here, let me just get this off, is insignificant. It's not there. 2 goes into 10 how many times? 5, right? 5. And then 5 times 2 is 10. Subtract that and you get a remainder of 0. And that's how we get 3.5, or 3 and 1 half, right? Okay. That's an improper fraction. And I want just to focus a little bit on a little bit more terminology. Remember that we said these are integers. These guys, if you take two integers and divide one by another, you create a rational, or you can get a fraction, right, or a rational number. And another thing to mention is that in any fraction, you can never have the denominator as 0. Just keep that in mind. That's something that everybody seems to forget. This is not going to happen. Or undefined. UDF. Not good. Right? A stands for any arbitrary number. We can just take any value. Say 2, for instance. 2 over 0 is not going to happen. Okay, so improper fraction, proper fraction. We've mentioned these as integers, right? So what else can we say about fractions? We said that this, so 7 halves, right? looking at 7 halves again, is either 3.5 equals to that, right? This is a decimal. This is it explained or demonstrated as a decimal, right? Or we have it in its mixed number format, meaning a whole and some fraction. So 3 is a whole and then some fraction. Think of it in pizzas. You have 3 entire pizzas and then you have half of another pizza that same size, right? So we can say mixed number. Oh, it almost stopped writing. This thing goes on and off. Number, right? This is again an improper fraction because the larger number is bigger than the smaller number. Right? Some terminologies to help you out. Cool? Okay, so as mentioned in class several times, there are 4 fundamental functions or processes that we rely on in mathematics. And those are division, of course, multiplication. Oh, ugly, but still, you get a point. Addition and subtraction. And I kind of grouped these 2 together because they go hand in hand, and addition and subtraction go hand in hand. So anytime you talk about addition, you can or subtraction, you can think about adding its inverse or adding the negative, right? When you're talking about subtraction, you're just adding negatives. And division and multiplication, they go hand in hand. You're just multiplying by fractions or whatnot. I'll give you an example in a little bit. So, if I take, this is a kind of a, we're going to work with the idea of a fraction, and then we're going to kind of put these into terms, right? Let's proceed with division and multiplication first of all. Oh, I don't need to rewrite it, but we're going to proceed with that first, right? We're going to proceed with that down here. Right? So, let's say multiplication. If I take 7 over 2 times, say, 3/5, right? Okay, 3/5, right? 2 fractions, and you can identify one as an improper right here, and this will be a proper fraction. Why? Because again, the denominator is greater than the numerator, right? So we have 2 fractions and we're multiplying them. What do we do? Well, I think in previous videos I stated exactly what to do, and I'll rewrite the rule down here. These I'm going to use as variables. These are just arbitrary letters or just fake letters that I'm using just to represent numbers. Alright? So if we have A over B times C over D, meaning 4 different numbers, as you see here, here, right? I don't think you could see that. Here, and each of these slots, each of these values are different from each other, right? That's what that's saying. So I have 4 different values multiplied, or in fraction format multiplied with each other. We're simply going to have it, or what's going to happen is you're going to multiply across AC over AD, right? Sorry, BD. Right? So that's what we're going to do. Let's follow that rule. So 7 times 3, 21. I'm waiting for an answer. I'm like, okay, I'm waiting. And then 2 times 5 is 10, right? Cool. So now we have another improper fraction, and if the rule states or the instruction states get it in its decimal format, then we can, again, this means this. 10 goes into 21. This guy is an operator. It tells us what to do. It's a function. It tells us this is an operator, this is a function. It says do this, commit this process, and then you will have me in decimal format. Okay? So 10 goes into 21, what we can say twice, right? 2 times 10. Subtract that, that's 11, right? Oh man, what's going on here? 11, right? Something's wrong here. It's supposed to be 2.1. The answer is 2.1. What did I do? 10 goes into 20. 2 times, oh, that's 20, sorry. No wonder. Yeah. Okay. My mistake. I make mistakes. I'm human. Actually, I'm coming down from a caffeine crash. Caffeine. Coffee. Starbucks. Blame it on the Starbucks. So we have 20. We're going to subtract these two, right? And we simply have 1, right? But 10 doesn't go into 1, so we add this point because in order to commit that, we're going to add a fake 0 or arbitrary 0, a trailing 0, right? And 10 does go into 10 one time, right? And then 1 times 10, 0. So here we go. 2.1. That's in decimal format, right? Cool. Now, let me move this up a little bit. I don't know what's going on. Here, let me get this guy. Okay, cool. Cool. Excellent. Now, you can review that. Again, keep that rule in mind. Right? Number 1, right? Okay. Let's move on a little bit. What if I had a mixed number? What if I had 3 and 1/4, right? Times, I say 2 and 1/5. Right? What do we do? And actually this came up today, except they were adding these guys. Well, my biggest suggestion is to convert them. You see a mixed number, convert it. Convert it and you know it's going to be an improper fraction. So when you do convert, again, we say this is the simplest way. You're going to take, here, I'm going to give you a different rule. A, B over C, right? That's what we see here. Well, I'm going to say it's going to be C times A. So you're going to multiply the denominator. Multiply this, A times C, right? So you're going to get AC after you multiply those two, and then you're going to add B to A times C. So you're going to add it, right? So you'll have AC plus B over C. Cool? So I multiplied AC, A times C, and then I added B over C. That's what I'm going to do for each of these. So every improper fraction, you're going to kind of respond promptly by using this. 4 times 3, right? 4 times 3 is 12, plus 1 is 13. So the first improper fraction is 13/4, right? And then the second one, 5 times 2, 10, plus 1, right? 11/5. And then we go back to this rule, number 1, right? I'm going to say number 2 here. Right? Let me erase this so you don't get confused. All right. We can simply multiply. That's a big number. 13 times 11, I think it's 123 over 20. And we can verify that. Let me see. 13 times 11, just to make sure. That's going to be 1, 3, right? And then we're going to have this guy right here. So it's going to be 3 and 1, right? 3, that's going to be 4, 143. What did I do wrong? Oh, I'm sorry. It's going to be, yeah. My apologies. By the way, if you guys ever want to multiply something quick by 11, okay, so for multiplying by 11, right? Just a quick side note, right? So we have 11 times 13. It's a 2-digit number that we're multiplying 11 by, these 2 digits, right? Simply add these 2 digits and then place it right in the middle between 11. So we have 3 plus 4, and 3 plus 1 is 4. And then you're basically just inserting these two that are added right in between here. So we have 11 times 16. Just add 6 and 1, we get 7, and place it right between here. So 171. Just a quick note. It's quick. That's for 2 digits, by the way. So when 141, sorry. What do we do? Oh dear. 143. Why am I having trouble with this? Let me do it again. I thought my little trick worked. I learned it from a book I read. So 1 times 3, 3, 1, then again 3 and 1. Oh, it's 143. I don't know, maybe my trick didn't work. Darn, to review that. 143. Okay, and if I'm wrong, I'm sorry. You guys can check the calculations, but I want you. What I'm trying to get emphasized here, and really centralizes the rules when multiplying fractions, and the rules when multiplying mixed numbers. Right? We have mixed numbers. We convert them. So we have a mixed number here. Mixed number, right? And then we convert it. So convert. Right? First of all, into fractions, and we have improper fractions, right? And then you can just simply multiply according to this rule up here, number 1, right? And then if my multiplication is off, apologies. I'm really bad at multiplying, you guys. Shame on me. Okay. All right. So, that's multiplication, right? What about division? Say if I were to divide. So this is kind of a new kind of problem, right? Say if I were to divide 3... oh, geez. This is ugly. I need more coffee. Okay. 3/5, right? Actually, no. Excuse me. I'm gonna say this instead. 3 over 2 over 5. I'm just making this up, you guys. Making it up. Bear with me, okay? Love you guys. Alright, so 2 over 5. Right. Okay, what I see here is a whole number, right? Right? Divided by a fraction. A rational number, what do you want to call it? This is actually a rational number too. Or fraction. Right? Or you can call it, be a little bit more specific and use that terminology and call it a proper fraction, right? So you'll be, yeah. Anyways, so by the way, mathematicians love it when you use jargon. So we have a whole number, 3, divided by a fraction, 2/5. So this is a new rule that states if you divide by a fraction, if you are dividing by, sorry, if you divide by a fraction, as we said, we're dividing by a fraction, which is 2/5, right? You can multiply by its inverse. An inverse. What the heck is an inverse? Inverse. That's an N right here. This is the N. Inverse. Or we can also simultaneously call it reciprocal. Right? Inverse is simply this. It's saying you're taking that fraction, 2/5, and you're turning it upside down, 5 over 2. Right? That's all you're doing. You're flipping it. We're taking the reciprocal. So what I'm going to do, instead of dividing 3 by 2/5, right? Dividing 3 by 2/5, a fraction, I'm going to multiply 3 by the reciprocal of 2/5. So taking 2/5, say instead of 2 over 5, I'm going to say 5 over 2. Now we can simply just multiply across, can't we? This is looked theoretically, not theoretically, but this is looked assumably, this is assumed to be 3 over 1. There you go. That's the word I'm looking for. So 3 times 5 is 15, divided by 2. Voila, your answer. Right? Okay, cool. Let me just do one more of these examples, and I'm gonna cut it short, and then we'll continue with more. Okay, one more. Okay, what if I have a fraction divided by a fraction? So that's a whole number divided by a fraction. In this example, A, we'll say B. What if I say 2/8 divided by 3? Give me, I was gonna say give me a number. That wouldn't work. I'd be waiting all day. All right. So again, this is a fraction divided by a fraction. You guys agree? I hope we all agree. I hope I'm right. If I'm not, shame on me. So a fraction divided by a fraction, 2/8 divided by 3/5. We can look at that and go, well, again, dividing anything by a fraction, dividing anything by a fraction, dividing anything by this fraction here, you can also multiply by its reciprocal. So I'm just going to take 2/8 on top, keep that consistent like we did the 3, right? The whole number, and then multiply by the reciprocal or the inverse of the denominator. So we have 3/5 in the denominator. We can just take its reciprocal. 5 over 3, right? And now we have 8/24, right? And we can even reduce that if we want. Right, so this can be further reduced. That's let me just again, by reducing, we're just taking we're trying to find common factors between the both so that we can cancel out and give us 1, right? So 2/5, and we can say 2 times 12, right? Okay, multiply that. 5 times 2, 10, 8, 16, 24. Just making sure. Now we have 2 over 2. We see 2 over 2 present. We go, voila, that's going to give us 1, and 1 times 5 over 12. Is simply itself, 5 over 12. I like to show that 1 sometimes because some people are. I want to really emphasize that this cancels out to 1, right? And 1 is assumed that's there. I always call it a chameleon. It just shows up out of nowhere. It's everywhere and nowhere at the same time, right? So 5/12 is our answer, and yeah, that. Oh, God. All right. Cool. Tubular. All right. So 5/12. Let me see how much time I have I've made you guys suffer. I'm still learning to work this, guys. Oh yeah, this is plenty of time. Okay. So what I'm gonna do is stop here, right, and continue in the next video. Thanks, you guys.